Welcome to the Deep Dive. Today, we're inviting you to consider, well, a pretty deep question. What does it really mean for an AI to understand something?
Yeah, beyond just, predicting the next word in a sentence.
Exactly. What if AI could grasp nuance, intent, maybe even evolve its understanding as context changes, like humans do? Imagine that.
It's a huge challenge, a really fascinating one,
Mm.
because current AI, well, it often struggles with those deeper layers of meaning,
Mm-hmm.
but that's precisely what we're digging into today, a system called Sophimatics, which is designed to tackle this very problem head-on.
Right. So our focus is Sophimatics, and it's a really groundbreaking concept, multidimensional semantic space. This deep dive, we're going to unpack how it's designed to move past those traditional AI limits.
Embedding those deeper layers of meaning we were just talking about.
It feels like a fundamental shift, potentially, in how AI could genuinely know the world.
Absolutely. Our mission here is to explore how Sophimatics aims to create AI systems that are truly understanding, adaptable, and capable of reasoning. We'll be looking right into its unique approach to making meaning.
And where are we getting our insights from?
Well, directly from the minds behind Sophimatics, Gerardo Iovan and Giovanni Iovana,
Yeah.
but also drawing on foundational research, people like McCarthy and Hayes, and empirical studies from RoBERTa and Leonard McMenemy, too, who've explored similar kinds of hybrid approaches.
Okay, so let's set the stage. Imagine trying to teach an AI the word star. Is it a celebrity? A thing in the sky? A symbol?
A classic problem.
Yeah, simple AI often gets tangled up there. Which brings us to the basic issue, the challenge of meaning. Why do these simpler AI models, well, fall short so often?
That star example is perfect. The biggest hurdle is what linguists call polysemy. One word, multiple meanings.
Like bank, riverbank, money bank.
Exactly. Without context, an AI is just lost. And earlier approaches, whether they were purely symbolic, rule-based, or purely connectionist, like neural networks on their own, they struggled.
They just couldn't get the whole picture.
Right. Studies showed they just couldn't achieve high accuracy, classifying linguistic and intentional representations together. They missed something.
And it's not just about the dictionary definition, is it? It's about what you mean, what you intend to do with something.
Precisely. That leads to what you could call the intentionality gap.
Okay.
Meaning isn't just what a word is. It's also about what can be done to something or, who cares about it. That intentional layer.
A lot of systems just miss that entirely.
They do. So the million-dollar question becomes, how do you build an AI that doesn't just crunch words, but actually grasps intent?
And that's where Sophimatics comes in, right? With this multidimensional semantic space.
Exactly. MSS. It's described as a high-dimensional feature architecture. That sounds complex, but basically it goes way beyond simple categories, linguistic or ontological.
So what's the key idea? What makes it different?
The critical takeaway is that Sophimatics isn't just processing data points. It's building a system designed to deeply embed meaning, context, intentionality, and even temporality, this sense of time.
That sounds much closer to how our brains handle nuance rather than just spotting patterns.
That's the goal. The core foundation, as Gerardo Iam and Giovanni Iovan laid out, is really acknowledging that vital interplay. Language, context, intentionality, they all work together.
It's not one or the other.
No, it's the synergy.
Okay, so how does it work? Maybe a simplified view?
Well, it uses a hybrid approach. It has distributed features. Think of it like a word's meaning isn't a single point, but like a pattern spread across lots of connected characteristics.
Okay, like a web of meaning?
Kind of. And then it uses localist layers on top of that to express specific relationships between those meanings. Things like is a part of or is caused by.
Gotcha.
But the real innovation, perhaps, is how it extends context into specific relational and adaptive domains. This helps eliminate those single-dimensional matching problems you see elsewhere.
Where an AI just matches a word based on one context, maybe the wrong one?
Exactly. Sophimatics aims to resolve those syntactic ambiguities dynamically on the fly.
Now that sounds fundamentally different from how, say, large language models like RoBERTa or ELECTRA work. My understanding is they mostly rely on co-occurrence statistics.
You're absolutely right. That's a key difference.
How often words just show up near each other?
Precisely. LLMs infer meaning from those co-occurrence patterns. Sophimatics, on the other hand, finds meaning based on a semantic weight.
Semantic weight.
Yeah, it represents the relationship between two domains, two areas of meaning, not just how often words are statistically nearby.
Ah, okay, so it's looking at the connection itself.
Exactly. This allows it to dynamically figure out those tricky ambiguities that LLMs, relying only on stats, might fumble. It's aiming for a deeper understanding because it's about the relationship of meaning, not just correlation.
Okay, this architecture sounds fascinating. Let's unpack that a bit more. How is this multidimensional semantic space actually constructed? You mentioned dynamic cognitive ontology networks.
Right, decons, they're a core component. What's really interesting is how they operate. They merge neuromorphic event processing.
Which sounds like it gives the AI a sense of time, like events happening in order.
You got it. It mimics how our brains process sequences and experiences over time. It merges that with something called tropical hyperdimensional representations.
Okay, that sounds complex. What's the essence of that?
Don't let the name intimidate you.
No.
Essentially, it provides incredibly flexible, vast ways to map out relationships between concepts, far beyond simple categories. It creates this remarkably flexible structure that can constantly adapt.
And adaptability seems key here, right? Especially when meaning changes or new information comes in.
Absolutely crucial. These networks use flexible semantic relations, like similardo, which might have a probability attached, or belongs-to, which might rank concepts by importance.
So it can adjust how strongly things are related based on new info.
Exactly. It adapts in real time to different information contexts. And we actually have some empirical evidence backing this up. McMenemy did a study.
Oh, yeah, you mentioned that earlier.
Right. His study showed a hybrid network, like this, achieved over 73% accuracy in a classification task. Compare that to an ontology-only network, which only got about 35%.
Wow, that's a huge difference.
It really demonstrates the power of this kind of multidimensional approach for better classification. It sees more nuances.
So the implication is moving away from building a static knowledge base, like a digital encyclopedia that gets outdated.
Towards a system that's actually designed to keep up with change, which, is vital today.
It's more like a dynamic learner than a static library.
That's a great way to put it. Adaptable systems need to maintain up-to-date domain information, that neuromorphic event processing we mentioned. That lets them incorporate time-sensitive weights, updating their understanding as things happen.
Okay, so dynamic networks are one piece, but Sophimatics also emphasizes deep ontology integration. What does that add to the mix?
Right, so besides the dynamic part, Sophimatics explicitly integrates rich, existing ontological knowledge graphs. Think of things developed by Bukowski and others, detailed maps of concepts and relationships.
Like vast libraries of established knowledge.
Exactly. They provide explicit meanings for thousands of classes and relationships. This is super important because, honestly, a big headache in AI has been the inconsistency between different ontologies.
Like different fields having their own jargon or ways of classifying things.
Precisely. You might have one for chemistry, ChemOnt, and another Chibi, and they just don't talk to each other properly. Different structures, different terms for similar things.
Ah, so they're like different dialects that make it hard for an AI to connect information across domains, say, linking a chemical property to a biological effect.
You've nailed it. That inconsistency really limits how you can combine them or generalize knowledge. Sophimatics tackles this by using that multidimensional space to merge and embed semantics across these different ontologies.
So it creates a kind of universal translator or a common ground?
In a sense, yes. It finds a way to represent them in the same space. This is something transformer models like RoBERTa or ELECTRA generally don't do. They usually work with non-integrated categories.
Right.
By creating this multidimensional and, importantly, explicit compositional ontology integration, Sophimatics aims to build more adaptable, scalable, and context-aware AI. Systems that are genuinely responsive and can reason with that integrated knowledge.
This is leading us towards something really interesting, the philosophical core. You mentioned Sophimatics aiming for true understanding, and this connects to ideas from McCarthy and Hayes about metaphysically adequate representation.
Yes, exactly. It's a profound point they made way back. McCarthy argued that no single, simple model will ever capture the full richness and complexity of the real world.
Like needing different kinds of maps for different purposes.
Perfect analogy. You need the road map, but also the topographical map, the weather map, maybe traffic data, all integrated to truly understand a journey. Sophimatics embraces this. It integrates multiple kinds of representations, maybe particle models, maybe wave functions, all connected back to natural language.
It's trying to capture the world adequately, as they put it, by accepting its messiness.
Precisely. By embracing that inherent complexity instead of trying to oversimplify it.
And it sounds like ordinary, everyday language plays a much bigger role here compared to many AI systems, almost like it's foundational.
It absolutely is. McCarthy strongly believed that ordinary language is fundamental for communication, not just between people, but between people and machines too.
Makes
So Sophimatics explicitly includes ordinary language within its semantic space model. And this, they argue, significantly strengthens its epistemic status, its actual claim to knowing things, compared to purely empirical AI that just learns patterns from data without that grounding.
So this multidimensional semantic space, it's not just a clever algorithm or a bunch of vectors. You're saying it represents an entire epistemic stance, a way of thinking about context, intentionality, and even dialogue in how meaning is made.
That's a really insightful way to put it. It redefines what AI knowledge could even look like.
How so? What's explicitly represented?
But what's fascinating is that philosophical categories, intentionality, phenomenological aspects like how things appear or are experienced, ontological content, what things are, these are explicitly represented within this space.
Wow. So the system uses this to reason not just about the facts, the content,
Yeah.
but also the reference, what the data actually points to or implies in the real world. It's trying to connect the symbols to reality more deeply.
Okay, what about something like ethics?
Yeah.
How does that fit in? Even ethical reasoning is seen as contextual and involving deliberation within this framework. So for example, if an AI using this had to weigh in on, say, a medical treatment decision.
It wouldn't just pick the statistically most common one.
Hopefully not. The idea is it would weigh different options based on explicit ethical considerations embedded within its contextual understanding. It would aim for what's ethically better through a kind of interval deliberation process using those embedded representations.
That is a massive leap. And dialogue, you mentioned dialogue earlier. How central is it? Is it just input or more?
Oh, it's fundamental. Intentionality, what something represents, why it's meaningful in context, is actually embedded into each semantic relation.
Okay.
But more than that, the very structure of these relationships is designed to be responsive to dialogue.
Meaning the AI's understanding can change through conversation.
Precisely. It allows the context of meaning to be constantly refined and updated through interaction. This is a huge differentiator from systems like RoBERTa or ELECTRA, where the underlying structure doesn't really change based on a conversation. They don't see dialogue and ethics as core parts of reasoning itself.
So it's not a static system trained once and set in stone. It's dynamic, it evolves, and critically, it refines its understanding by engaging, hopefully in a truly meaningful way. That's quite a vision.
It really is. By merging generative AI capabilities, that deep ontology integration we discussed, and neurosymbolic representation, Sophimatics is, well, incredibly ambitious. But this integration, delivered to these dynamically built semantic spaces, aims to achieve something current state-of-the-art approaches, frankly, cannot.
Which is?
Flexible, context-embedded meaning-making that can grow organically with new data and is genuinely responsive and capable of reasoning, not just pattern matching.
It really sounds like Sophimatics is being positioned as a core step towards AI systems that might be capable of something closer to true understanding, giving it an advantage that current LLMs don't have and maybe architecturally can't achieve.
That seems to be the argument, yes. It's about moving beyond just statistical correlation towards something much more akin to how humans reason, connect ideas, and, well, understand.
Okay, so let's recap this deep dive. Sophimatics' multidimensional semantic space looks like a potentially significant leap in how AI might process and truly get complex information.
Yeah, by integrating context, intentionality, and that temporal dimension in ways traditional AI really struggles with.
It's trying to move beyond just recognizing patterns to actually grasping meaning, genuine meaning making.
It's a profound shift in perspective, moving from AI that predicts based on statistical patterns towards AI that aims to understand the why and the how of meaning, building a system that is maybe capable of learning what it means to care about the information it processes.
Which leaves us and you with a really thought-provoking question to ponder. What are the implications if AI systems can genuinely understand context, intent, and maybe even ethical nuances? What if they can adapt their understanding through dialogue?
How could that change everything?
Exactly. Think about human-computer interaction, AI's role in really complex decision-making.
Yeah.
Could we move beyond just sophisticated statistics to something truly closer to human reasoning, perhaps even touching on wisdom? Lots to think about there.